Okay, so today we're going to take derivatives of inverse functions, but let's review real quick what an inverse function is. So we see this f to the negative 1 power is typically how we talk about an inverse function in symbols. And numerically, it's the switching of the x and the y values, or switching of the input and the output. So whatever goes into the inverse is what came out of f, and whatever comes out of f inverse is what was the input for f. Graphically, this is a reflection over the line y equals x. So, for example, if we graph y equals x cubed, and we want to find the inverse graphically, we would want to find the reflection in the line y equals x. And so that would look like this for the top part, and this for the bottom part. And this is actually the equation we'll find in a second. That's the inverse of x cubed, which you might already remember what that is the equation of. And if we wanted to find that equation analytically, we would start with y equals x cubed. Usually we start by switching the x and the y values, and then we solve for y. So here we would take the cube root of both sides, and we get y is equal to the cube root of x. And so that is the inverse if f of x is the starting function x cubed. So this guy here, this green one, is the cube root of x. Okay, so now let's talk about taking derivatives. So we will first take the derivative with method 1. This is not usually ever expected to be used on the AP test, but I want you to understand what we're doing here. And often it's like impossible to do this. Okay, so we'll show you method 2 in a second. But for now, let's talk about this first method. So first it would be to actually find the inverse by the method that we just did, changing the x and y, solving for y, and then take the derivative of this new function, and that would be the derivative of the inverse, and then plug in whatever value you're looking for, okay? So we're going to do that here with this example. So if f of x is equal to x squared for x greater than or equal to 0, and we want to find the derivative of inverse at x equals 4, we could start with finding the inverse. So if f of x is equal to x squared, we would start with y equals x squared. We're going to do the method we just did a second ago. Switch the x and the y values. Solve for y, so take the square root of both sides here. And typically we would talk about this being plus or minus the square root of x, but since x has to be greater than or equal to 0, that means that y now, since they switch spots, has to be greater than or equal to 0, so we're only talking about the positive version. So f inverse here will be the square root of x. And then if we want the derivative of f inverse at x equals 4, in step B here, we could take the derivative of this guy. So we could take the derivative of f inverse. We already know that's 1 over 2 square root of x. And then they are asking us to find the derivative at x equals 4. So to find f inverse derivative at 4, we would just simply plug in 4. So we would have 1 over 2 square root of 4, or 1 over 4. So usually you're not going to use this method on the AP test, because a lot of times it's not as a nice function as x squared, and it's really hard to solve for the actual inverse, okay? So now let's talk about another way that you could do this, okay? So we would do this in a lot of cases is after you switching the x and y, you're solving for y is really, really hard. So that's one way that you might not be able to find the inverse. So is that you couldn't solve for y, right, after you switch the x and y's. So in this case, we would still find the inverse by interchanging x and y. we just would not solve for y, because that's going to be really, really hard. Then we would go ahead and find dy dx implicitly, and then solve for dy dx. It will be in terms of y in this case, and then we would replace the value in our inverse that we wanted to find. So we're going to do an example of that here. So let's start by first, or let's back up here so we can see the instructions. First, we're going to find the inverse by interchanging x and y. So here we will let f be x, and we'll have y cubed minus 4y squared plus 7y minus 1. But we're not going to solve for y, remember, because this is going to be pretty hard to solve for y in this case. So since that's not possible, we're going to find dy dx implicitly. So that's what we did in this last unit. So we're going to take the derivative of both sides with respect to x. So the derivative of the left side will be 1. Derivative of y cubed will be 3y squared dy dx. Derivative of negative 4y squared will be negative 8y dy dx. Derivative of 7y will be 7 dy dx. And derivative of negative 1 will be 0. So then we'll factor out our dy dx like we usually would when we're doing implicit differentiation, and then we'll divide. So we'll have that dy dx is equal to 1 over 3y squared minus 8y plus 7. And then we're looking for the derivative of the inverse function at x equals 1. So here, this here is the derivative. Well, I'll just write it down here. So this right here is dy dx. So this is the derivative of f inverse for the y value. And even though this says x is equal to 1 here, we can still figure out what the y value is that corresponds to that, because we need to be plugging in the y value into f inverse. So if we do that, we could figure out, if we can figure out what the y value is, then we can plug it in. So now you have to figure out what the y value is. Well, that is not a big deal because we have an equation for our function in terms of y, and we just need to figure out what y is. So if we go back to this equation right here, we're looking for what y is when x is equal to 1. So plug in x equals 1. And if we solve that for y, then that will tell us our y value that we need to plug in here. Now this one, you would not be able to solve by hand. You would have to use your calculator. You could use the solve command here on your calculator if you wanted to do that. When you do that, you're going to get y equals 0.349. And then you can go ahead and plug that into your inverse derivative for y. So then we'll say, okay, what is the derivative of the inverse at 0.349? So we're plugging it into this equation here. If you want to do that on your calculator, this is kind of a way that you can go ahead and do that without typing in the answer every single time. And if we do that, we'll get 0.219. Okay. So let's do one more example here. And we're going to find the derivative of this guy here. Find the derivative of the inverse of this guy. And we're going to solve it in the same way that we just did a second ago. So we'll start by finding the inverse by switching x and y. So when we do that, we'll have y is equal to, oh no, sorry, we'll go ahead and switch them. Let's not write it down. So x is equal to e to the y plus ln y. So this is the inverse. It's just not solved for y. Solving for y here would be really difficult. So this is the inverse of f, it's just not solved for y. So then we're going to take the derivative implicitly. So take the derivative of x on both sides, and we'll get 1 is equal to derivative of e to the y is e to the y times dy dx. Derivative ln of y is 1 over y times dy dx. We'll factor out our dy dx. We'll be left with e to the y plus 1 over y, and then on the other side we have 1. And so dy dx will be equal to 1 over e to the y plus 1 over y. So remember, this is now the derivative of f inverse at y. Now, unfortunately, we only know the x value at 3, so we would need to find the y value that corresponds to that. So the next thing that we would do is we would take our original equation, or not that one, sorry, the one with y in it, and we'd plug in x equals 3. I mean, in reality, you can plug it into either one. It doesn't really matter, as long as you're getting out the y value. So you could also plug it into this one, because it's going to give you the y value either way. But this is what I went ahead and did. So we're going to plug 3 in for x into this equation over here, and we'll have e to the y plus ln of y. That's not going to be fun to solve by hand, so on our calculator, we could solve that like we did before, and we'll get y is equal to 1.074. And so then we would just need to plug that value into this derivative here. And when we do that, we will get 0.259. Alrighty. So now let's go ahead and look at one last method that will make our lives a lot easier. Okay. Method 2 is pretty tedious because you have to find the corresponding y value. Well, I'm going to show you a method that you can do that you basically do need to find it, but it's going to be a lot easier, and we're going to streamline it, okay? So this says that if you're trying to find the derivative of the inverse function, that it will be 1 over the derivative at f inverse of x. So this is now the y value for f inverse, okay? So basically what we're talking about here is there's a special relationship between the derivative at x, if we're at a point xy. The derivative at x is the slope of the tangent line, right? And the derivative of the inverse at y, so the y value at that same point, this derivative will always be the opposite reciprocal of that slope. So that's why this works. So let's go ahead and use this. This is what you'll end up using the most on the AP test. We're going to go ahead and use this definition here. So it says, find the derivative of the inverse function f of x at x equals pi using the formula above. So we're going to use this formula. So to find the derivative of the inverse function, first we're going to find f prime of x. That's what we need first. So we'll find f prime of x first, actually. So that'll be 1 plus cosine x. And then this inside part, right? So for us, our problem, f inverse derivative, we want that at x equals pi, will be equal to 1 over f prime at f inverse of pi. Right? So as long as we can figure out what f inverse of pi is, all we have to do that is plug that into the derivative. So now we'll go ahead and find f inverse at pi. And this is exactly what we did the last time. So you're just finding the y value that goes with that x value, okay? So we're just trying to find that y value. So if we switch our x and y values here, we'll have x is equal to y plus sine of y for our inverse. So we just need to find f inverse at pi. So now if we plug in pi for x, we get y plus sine of y. And you could solve this with your calculator, but it actually might be a little bit easier just to kind of do in your head, because if you think about this, like, okay, we need to get pi. Well, if you plug pi into sine, that's 0, and then you add pi again, then you get that. So this is y equals pi. So you can solve that in your calculator, but it might actually be easier to solve in your head. Okay. Now just a note here, okay, we were not able to plug in pi in there for x. We had to plug it in here for x, because remember this is the value at which we're finding the derivative of the inverse, right? So this x is the x for the inverse, right? So that's a y value on f. That's why we had to be careful there, and that's why it goes on the other side. Okay, so just a reminder there. Okay, so now that we figured out what y is, that is f inverse at pi, right? So this is the x value for f inverse, and now we just found that y value for f inverse. So now we just get to plug it in to our little equation here. So if we take this and we say, okay, then we'll have f inverse prime at pi will be equal to 1 over f prime at f inverse of pi, which is equal to pi. So that'll be actually equal to f prime of pi. So both the x and y values are pi here, so it's a little confusing on this one. And then we already found what f prime was. That was this guy here. So we just need to plug that in there. So it'll be 1 over 1 plus cosine of pi. And cosine of pi is equal to -1. So this will be 1 over 1 minus 1, which will be 1 over 0. So this is really undefined here. Our derivative is undefined. Okay, so let's do another one here. Okie dokie, so we're going to here use our definition from above. So we want the derivative of the inverse at x equals 3. So we're going to find the derivative of f inverse at 3. So remember, x is a 3 for the inverse. I'm sorry, 3 is the x for the inverse. And this will be 1 over f prime at f inverse at 3. So first we need to find f prime. So just using our power rule here, f prime of x will be 3/4 x squared plus 1. And now we need to find f inverse at 3. So to find f inverse at 3, we're going to take 3, and remember that is now so that's the x value for the inverse, so it's the y value for f of x, right? So we're going to switch the x and y values to get our inverse. So we'll have 3 in for the y value. 3 in for the x value. And then we'll switch our x's to y. We can solve this with a calculator. Technically, you could try to solve it by hand as well. But really here, again, you can kind of just like guess what it is pretty easily here by looking at what y needs to be, and you'll get y equals 2 if you do it either way, okay? So f inverse of 3 is going to be 2. Remember, it's a y value because it's a y value of the inverse, which is the x value of that guy, okay? And so f inverse of 3 is equal to 2, so now we can take our formula here and find the actual derivative that we're looking for, and it will be 1 over f prime at 2. And so we can plug f prime of 2 into our derivative. And so we'll get 3/4 times 4 plus 1, which will just be 3 plus 1, which is equal to 4. So our derivative of our inverse will be 1/4. So notice how the derivative is 4 and the derivative of the inverse is 1 over 4, right? That's that slope thing that I was talking about. They're always going to be reciprocals of each other, okay? So let's do one more example here using a table, okay? So we're going to find the derivative of g inverse at 1. So we'll use our definition here. This will then be equal to 1 over the derivative of g at g inverse of 1. Now we just get to use our table to find these values. So remember, if these are the x values for g, then these are now y values for g inverse, right? So they'll switch inputs and outputs, right? So these are the y values for g, and these are the x values for g. So for g inverse, they have switched, right? So g inverse of 1, we're going to go look at what's the output of 1, and then ask ourselves what the input was that belonged to that. So that's -1. So this will be 1 over g prime of -1, and g prime of -1 is equal to -1/5. That we're just reading from our table. And so this will be 1 over -1/5, or -5. Remember, they're opposite reciprocals of each other. Or not opposite, just reciprocals of each other. Okay, and so then one more using this, and this is where these usually come into play on the AP test. We'll take the derivative here, so this will be 1 over g prime at g inverse of -3. So first we'll find g inverse of -3 on our table. So remember, those are now your outputs. So you're going to go to -3 on the output and look at what was the input for that. That'll be g inverse's output. So that's 4. So now we're going to have 1 over g prime of 4. And we can look at our table to find what g prime is at 4. And that's -2. So this will be 1 over -2. All right, that is it.